Black holes devour everything. But what if there's something that does the opposite? A place where time runs backward and reality gets thrown out, not pulled in. We call them white holes, and if they're real, they might just be the weirdest things in the universe. A white hole is what happens when you take a black hole and reverse time, literally. In general relativity, the equations that describe a black hole have a time-reversed twin, and that twin is a white hole. Where a black hole pulls in everything, even light, a white hole pushes everything away. You can't fall into one. Not even light can enter. Instead, a white hole erupts. It spews out matter, energy, light, like a cosmic volcano that can't be approached, only observed. It's as if the universe has a one-way valve. Black holes devour, white holes regurgitate. Nobody's ever seen one, they might not even exist, but mathematically, they make perfect sense. In 1915, Einstein gave us general relativity, a theory of gravity that doesn't just bend space, but twists time itself. Just months later, Carl Schwarzschild found a solution to Einstein's equations, a strange one. It described a singularity, a point where space and time break down, surrounded by an invisible surface, the event horizon. That solution was the first black hole. But here's the twist. If you fully extend that solution, take the math to its logical extreme, you don't just get a black hole, you get a white hole too. Connected to the black hole by something called an Einstein-Rosen bridge, what we'd later call a wormhole. On one end, matter falls in and disappears. On the other, it erupts outward and can't be touched. It's pure mathematics, but it poses a tantalizing question. What if these objects aren't just abstract solutions, but real parts of our universe? On paper, white holes are flawless. They're demanded by the same math that gave us black holes, and black holes are very real. But here's the problem. White holes are unstable. If even a single atom of matter approached one, it would break the equations, and the whole thing would collapse. That's why many physicists thought they were just a mathematical curiosity, like imaginary numbers, useful, elegant, but not real. But then quantum gravity stepped into the conversation. Some researchers now think black holes don't die in silence, they bounce. In loop quantum gravity, a theory of quantum gravity, as a black hole collapses under its own weight, quantum forces resist total destruction. And eventually, boom. It rebounds, not as a black hole, but as a white hole. What falls in might one day come back out. Some even speculate that certain gamma-ray bursts, brief, brilliant explosions in deep space, might be white holes flickering into existence for a split second, then vanishing. No one's proven it yet, but the idea is gaining traction. Because in a universe this strange, nothing's off the table for long. So what would a white hole look like, you ask? Imagine a place in space where matter is exploding outward, but you can't go near it. A blinding eruption of energy, light, dust, pouring from what looks like empty space. No star, no planet, just chaos. It would look like something being born from nowhere. No pull, only push. From a distance, it might resemble a supernova. Up close, assuming you could even get close, the laws of physics would fall apart. You couldn't orbit it, you couldn't enter it. Every attempt to approach would just bounce you away. Unlike a black hole, it doesn't trap light, it floods it. If they exist, white holes might be some of the brightest, most short-lived objects in the universe. Not peaceful beacons, but violent expulsions, like the universe is exhaling something it could no longer hold in. Here's where white holes stop being just rare cosmic phenomena and start sounding like keys to the entire universe. One theory suggests that our Big Bang, the origin of everything, was actually a white hole. Instead of a singular beginning, it was matter erupting from another part of the cosmos, or even another universe. In this view, black holes in our universe might be connected to white holes in another. Every time matter falls in, it's not destroyed, it's moved through a wormhole, through time, through dimensions. Some physicists believe white holes could be the ultimate recyclers, taking the compressed, dying stars of one cosmos and birthing stars in another. Others go even further. What if white holes are gateways between universes? Or evidence of higher dimensional physics we're only beginning to glimpse? In some theories, even information lost in a black hole, something Einstein hated, is restored by the white hole. The universe, it seems, may never forget. Right now, white holes live in equations, not telescopes. We've never seen one. We've never measured one. But the maths is elegant, the logic is sound, and sometimes in physics, that's enough to make people look harder. Maybe they're real, maybe they're rare, maybe they're hiding behind phenomena we've already seen, cloaked as supernovae or gamma-ray bursts, misunderstood and misnamed. Or maybe white holes aren't real at all. Maybe they're a mirage, a necessary shadow cast by black holes, useful only on paper. But here's the truth. Every time we thought something in space was impossible, we were wrong. Black holes were once pure theory. So were gravitational waves. So was the idea that time could bend. The theory of relativity shattered all of these beliefs. And that was done just with one quirky guy with paper and a pencil. And of course, a giant brain. So maybe, just maybe, somewhere in the far reaches of space-time, a white hole is erupting, alone, unseen, rewriting matter into something new. And if it is, we should be listening. If white holes are real, then they aren't just strange. They're revolutionary. First, they challenge the arrow of time. Black holes pull in, white holes push out. One represents collapse, the other release. If both exist, then time might not flow in one direction after all. It might loop, or mirror, or even rewind. Then there's the black hole information paradox. Physicists have wrestled with this for decades. If black holes destroy information, that breaks quantum mechanics. But if they become white holes, if the information eventually comes back out, then the paradox dissolves. White holes don't just restore balance, they might save physics. And what if they go even further? What if the Big Bang itself was a white hole? Not a beginning from nothing, but the rebirth of something old. A dying star in another universe, a black hole that collapsed and bounced. In that view, we're not living in the first universe, we're living in a sequel. But here's the wildest part. What if white holes explain one of the universe's biggest mysteries? Dark matter. Some ideas have even suggested that the universe is littered with tiny white holes. Not the blazing, short-lived kind, but stable, ancient remnants of evaporated black holes. No light, no heat, just mass. This would explain why there's more gravity than there should be. Far more. They'd be invisible, undetectable by normal means. But their presence would bend space, shape galaxies, hold everything together. And if black holes really do connect to white holes, through tunnels in space and time, then the universe may not be as divided as we think. Maybe creation and destruction are just two sides of the same door. And white holes are the proof that somewhere out there, nothing is ever truly lost. If you're still here, you're one of us, and welcome to the growing Stellar Stories crew. You're someone who looks at the night sky and wants more mystery, more wonder, more truth. So, subscribe to Stellar Stories for videos about black holes, alien worlds, consciousness, and all the strange beauty the universe refuses to explain. I always respond to comments. See you next time.